Here we want to find out which equation corresponds to which graph. Notice first of all that these both have a y-intercept of 2. That corresponds to this point on the graph. That is not going to help us solve our problem, but it is interesting. We'll need to use the growth factor. Now, one way of solving this problem is to compare the graphs to a flat line. That's not an exponential function. It is a linear function that's got the equation y equals 2. You could also write that as 2 times 1 to the x power. Because if you take 1 to any power, you're going to get 1. 1 times 2 is 2. Now, whichever of the two graphs is closer to that line, that's going to be the graph whose growth factor is closer to 1. And here you see it. This one of the two that we've got here is closer to 1. So the flatter graph is going to be that one. And of course that leaves the other graph as y equals 2 times 2.5 to the x. Another way of doing this is to make a table of values. And you don't need many points in your table of values. In fact, you just need 2 points. This will be 2 times 2.5 to the x. If we put 0 in for x, of course we get 2 for y. If we put 1 for x, we'll have 2 times 2.5 to the first power, which is this 2.5. So that gives us an output of 5. Let's do the same thing with the other equation. When we have 0 for x, we have 2 for y. And when we have 1 for x, we have 2 times 1.2 gives us 2.4. Which graph is growing up faster here? Well, obviously, it's the one that has 1 in, 5 out. That's going up faster than having 1 in and 2.4 out. So this will be the one that has the steeper curve. And if you look at our graph, that's exactly the one we selected for this equation, the one that's steeper.